Hello everyone, welcome to MCP Server Masterclass. If you ever wondered how your AI application like ChatGPT can talk to your own application or how to build a smart integration using Model Context Protocol, you are in the right place. There are a lot of confusing content out there, scattered tutorials, outdated docs, but this is the only video you are going to need to go from zero to advanced level. I might be a bit late to the tent, but I have packed this tutorial with clear explanation, real coding example that you won't find anywhere else. Moreover, I'll share some pro tips that is going to help you a lot. So stick with me. At the end of this tutorial, you are going to build your own MCP server. Here is what we are going to cover today. We are going to learn about what is MCP server. We are going to learn about architecture of MCP server. We are going to use transport layer. We are going to create a Python project with UV, which is a new package manager. We are going to use Google Auth and Google Calendar API as well. We are going to use Cursor as a MCP client. We are going to learn about MCP client. We are going to use MCP interceptor, and there are two transport layer we are going to use in this video. One is MCP server using stdio, another one is streamable HTTP. MCP, Model Context Protocol, is an open source standard for connecting AI application to external systems. Using MCP, AI application like Claude or ChatGPT can connect to data sources, local files, databases, tools such as search engines, calculators, and workflows such as specialized prompts, enabling them to access key information and perform tasks. Think of MCP like USB-C port for AI applications. Just as USB-C provides a standardized way to connect electronic devices, MCP provides a standardized way to connect AI application to external systems. AI applications such as chat interfaces, IDEs, or code editors, for example, Claude Desktop, LivaChat, Visual Studio Code, often need to access real information like files, logs, or database content. Instead of connecting directly to each tool or data source, those applications use Model Context Protocol, or short form MCP. AI application, also called the MCP host. This is the main software the user interacts with. It manages the coordinates connection to multiple MCP servers. MCP follows a client-server architecture, where MCP host an AI application like Claude Code or Claude Desktop establish connection to one or more MCP servers. As I said earlier, MCP host is an AI application that coordinates and manages one or multiple MCP clients. MCP client is a component that maintains a connection to the MCP server and obtains context from an MCP server from the MCP host to use. MCP server is a program that provides context to MCP clients. For example, Visual Studio Code acts as an MCP host. Your API gateway, authentication, validation, queues, routes, all those are MCP hosts. MCP consists of two layers, data layer and transport layer. Data layer defines the JSON RCP based protocol for client-server communication, including lifecycle management and core primitives such as tool, resources, prompts, and notifications. Conceptually, the data layer is the inner layer, while the transport layer is the outer layer. The transport layer manages communication channels and authorization between clients and servers. It handles connection establishment, message framing, and secure communication between MCP participants. MCP supports two transport mechanisms, STD-IO transport and streamable HTTP transport. STD-IO uses standard input-output streams for direct process communication between local process on the same machine providing optimal performance with no network overhead. On the other hand, stable HTTP uses HTTP post for client to server messages with optional server sent events for streaming capabilities. Primitives are most important concept within MCP. They define what clients and server can offer each other. These primitives specify the types of contextual information that can be shared with AI application and the range of action that can be performed. MCP defines three core primitives that server can expose: tools, resources, and prompts. We are going to learn all of them by coding. Additionally, MCP defines primitives that client can expose. Those primitives allows MCP server authors to build richer interactions, sampling, elicitation, and logging. Here are some of the use cases of MCP server. You can see in the chart. Cursor, for example, can call tools resources by command line. Gemini browser can expose the streamable HTTP transport and consume it. Slack or Discord bots call MCP tools as backend actions. Web apps uses HTTP transport to interact with calendar events dynamically, which we are going to do in this tutorial. For local automation, we can use stdio transport for scripts. Okay, enough explanation. Now let's get into the code.